Hi everybody, welcome back. This is Chemistry, Unit 8, Lesson 6. And we're discussing the mole relationships. Yesterday we learned that a mole is a unit, or have you heard, containing 6 times 10 to the 23rd. So we learned yesterday that a mole contains 6 times 10 to the 23rd molecules, or atoms. So we could convert between molecules and moles and moles and molecules. The problem is, if I asked you to go get me 5 moles of water, it's not like you can see molecules, and it's not like you would want to count to 6 times 10 to the 23rd. So we need a better way, a more practical way to measure moles. And so what we came up with is that 1 mole is always equal to the formula mass of a substance. So if you want a mole of carbon atoms, since the formula mass of carbon is 12 grams, you would need to weigh out 12 grams of carbon. If you want a mole of sulfur, sulfur's formula mass is 32, you'd weigh out 32 grams of sulfur. If you want a mole of mercury, mercury's formula mass is 200.6 grams. So you'd weigh out a mole of 200.6 grams, and you'd have a mole of mercury. If you wanted a mole of iron, you would weigh out 55.8 grams, because this is the formula mass of iron. So a mole of each of these substances, notice, is a different number of grams, but they would all contain the same number of atoms. They all have in them 6.02 times 10 to the 23rd atoms. Okay? So we can then relate mole to mass. Okay? And the idea is that 1 mole of a substance always equals its formula mass in grams. So if we are given moles, and they are asking us for mass, we're going from moles, therefore we would multiply, and what we would multiply by is the formula mass, which again, I'm not going to write out formula mass each time, it's just Fm. So unlike molecules where we always use the same number for everybody, here this number is going to be different. It depends on the formula mass. If you're going the other way, if you are given mass and they ask you for moles, well, in that case, you're going toward moles, and therefore you would divide by the formula mass. This is actually the only, there are 3 relationships about a mole we're going to learn. This is the only one that's given into your reference tables. This is actually given in reference table T as in Thomas. Okay? So these ones are a little bit longer because you actually have to stop and calculate formula mass if they don't give it to you. So example number 1, how many moles are present in 180 grams of NaOH? So they are giving us, find the number, underline it, they're giving us 180 grams. Grams is the unit of mass. We know that. They are asking us how many moles. So in this problem, are you going from moles or toward moles? What's your guess? Hopefully you said toward moles. You're trying to find moles. And if you're going toward moles, since toward ends in a D, you're going to perform the mathematical operation that starts with a D. You're going to divide. And what you're going to divide by, when the relationship is between mass and moles, is the formula mass. So I have to stop now and get the formula mass of NaOH. Na has a mass of 23. Remember, it's the mass of all the elements added together. Oxygen has a mass of 16, and hydrogen has a mass of 1. So the formula mass for NaOH is 40, which means 1 mole will equal 40 grams. Well, we have 180 grams, so obviously we have more than a mole, right? We're going to take 180 grams and divide it by 40 grams per mole. And that will give us the number of moles in our answer, which should turn out to be, if we put it in sig figs, 180 divided by 40 is 4.5. And that's actually improper sig figs because this number only has 2 sig figs, right? The trailing 0 doesn't count because there's not a decimal point in the number. Okay, example number 2. What is the mass of 3 moles of copper? We are given 3 moles, and they are asking us for mass. So how about in this problem? Are we going from moles or toward moles? Hopefully you said from moles, because you're given moles. If you're going from moles, from ends in an M, you're going to perform the mathematical operation that starts with an M, which is multiplication. And when your relationship is between mole and mass, you multiply by the formula mass. Okay, now it's just the element copper. So we just go and look up the formula mass of copper, which is, I think, 64. Okay, let me look at my reference tables and just be sure, because I don't want to give you a wrong answer. Yeah, it's 63.5, which rounds up to 64. So we're going to take our 3 moles and multiply it by 64 grams per mole. Right, grams in 1 mole. So 3 times 64 will give us our mass of 3 moles of copper, which is 192, I think. Oops. Okay, now if we're expressing that in sig figs, and again, you only have to do sig figs unless the problem specifically asks you. So it's really not necessary here. You could just leave it in as 192. But that has 1 sig fig. So I would round this in sig figs to 200 grams. Okay? All right, you have example number 3 and example number 4 here. I'd like you to do those ones for tomorrow on your own. And I'd like to talk about the final relationship with the mole. So we know 2, right? 1 mole equals formula mass. 1 mole equals 6.02 times 10 to the 23rd molecules. There is one more relationship that you need to know, and that is the mole and volume. Volume is only of a gas, and that gas must be at STP. So this won't work with the solid and this won't work with the liquid. It'll only work with the gas at STP. And 1 mole of any gas always occupies 22.4 liters. So this one is different because it's not for everybody. It's only a gas at STP, and it occupies 22.4 liters. If you have a gas at STP, 1 mole of it, it'll occupy 22.4 liters. Think of about 11 2-liter soda bottles. That's what we're talking about, okay? How can you convert moles to volume? Well, if you're given moles and they ask you for volume, remember volume will be in liters. They'll ask you for liters. You're going from moles, therefore you would multiply by the magic volume number, which is 22.4. Okay? However, if you're going the other way, if you're given volume and they ask you for moles, well then you're going toward moles, so you would divide by 22.4. If you don't have a gas at STP, you cannot use this relationship. So this is super duper 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 important. Okay? A container with a volume of 101 contains how many moles of argon gas at STP? Okay? We have a gas at STP, which means I can use the relationship 1 mole equals 22.4 liters. Otherwise, you could not use that relationship. We are given 101 liters. They are asking us how many moles. So Kevin, are you going from moles or toward moles? Toward moles. Very good, Kevin. So you divide by 22.4. So you're going to take 101 and you're going to divide it by the magic volume number, 22.4. And you got 4 point, oh, now see, this is where sig figs comes in handy. Because you get a really long number. And I don't feel like writing that long number, so I'm going to round it to the proper sig figs, which is 3. 4.51 moles. That's why I love sig figs, because then I don't have to write out the whole big, long, stinking answer. Okay, in example number 2, what is the volume of 2.5 moles of neon at STP? Again, we have a gas at STP, so we can use that 1 mole equals 22.4 relationship. We are given 2.5 moles, and they are asking us for volume. Okay? So in this case, we're going from moles. Whenever you go from moles, you multiply, and since you're converting between mole and volume, it's your magic volume number, 22.4. Okay? So you're going to take your 2.5 and multiply it by 22 point, well, not bad, 22.4. And you come up with 56. Okay? Again, if you like the dimensional analysis, you could always use dimensional analysis for any of these relationships. I'll just walk you through dimensional analysis for the next one. We are given moles, and they're asking us for volume. So the unit we want to get rid of goes on bottom. The unit you want to convert to goes on top. I'll just put liters, right? That's the unit of volume. And then the conversion factor, the relationship gets plugged in. 1 mole always occupies 22.4 liters. Remember, when you're doing dimensional analysis, what you're given always goes in the denominator, the unit, and what you're converting to goes on top. You multiply by all the tops, divide by all the bottoms. So just like if you were doing it the regular way, you're going from moles, you multiply by 22.4, you can see you're doing the same operation when you use dimensional analysis. I really just put that up there for Erin because I know Erin likes the dimensional analysis. Erin, you could also do this with formula mass, okay? So we're going to get 89.6 liters is our answer. Okay? I'd like you to finish up example number 4 for tomorrow, and that is it for tonight, everybody. Have a great night. Bye-bye.